अच्छा जी, today is 21st January 2026 and we are solving and drawing questions on refraction of water waves. Right now we are solving the mathematical part of the question. The mathematical part of the question is the speed of wave in shallow water is zero point 0.6 and the speed of water wave in deep water is zero point 0.8. You are given wavelength. Wavelength, is the separation between wavefronts. It is given 1.4 centimeter, and we have to calculate wavelength in shallow water. Okay, so now we are going to solve this question. And remember, if the two quantities are directly proportional, so we can use cross multiplication. If the two quantities are directly proportional, then we should use cross multiplication. And in cross multiplication, you do not need to convert units. You do not need to convert units. You can see velocity is in meter per second and the wavelength is in centimeter. And without converting unit, I am solving question. Sir, why? Because unit on either side will cancel out each other. So in cross multiplication, you do not need to convert unit. Okay. So if you cross multiply, then obviously meter per second will cancel out on either sides. And now you can calculate wavelength in shallow water. It will be zero point 0.6 divided by zero point 0.8 into 1.4. But Rafe, can you answer me? What is the wavelength of water wave in shallow water? Rafe, what is the wavelength? Can you help me in calculation? And Arisha has sent me again the okay, okay. अच्छा बेटा Arisha, I think your diagram is not good. And if you look at this diagram, then this diagram is quite better. Okay. So I think your diagram is not good. काम चलेगा, but it is not good. ठीक है ना? तो उसमें एक तो आपकी कैमरे की पोजीशन भी थोड़ी सी पोर्ट्रेट में नहीं है शायद. अच्छा जी. Now we are solving another question. राफे आपने हमें आंसर किया. What will be the wavelength? 1.05 and it will be in centimeter because the given wavelength is in centimeter. So the final answer will also be in centimeter. So this question is completed and now we are moving forward to another question. And this question is from June 2015 paper. Again, so this is a boundary. This is a boundary. And on this boundary, so this is wavefront number one. And obviously this wavefront bending towards the boundary. This is wavefront number two. And this wavefront number two will be parallel to the first one. But Arisha, your wavefronts are not parallel. I think you are all wavefronts in the shallow region starting from a single point. And I am drawing wavefront from the edge of the incident wavefront. Arisha, beta, are you listening? Your wavefronts are not parallel, I think. Huh? So you should draw wavefronts like this, in which all the wavefronts are parallel to each other, as well as you can see the separation between the wavefronts represent wavelength, and in faster region, the wavelength is longer, and in slower region, the wavelength is shorter. So wavelength decreased, okay, the wavelength decreased, as well as if you are given a diagram, and in this diagram, the you are given this condition, so this is the scale diagram. This is a scale diagram, okay, and in this scale diagram, 1 centimeter drawing actually equals to 4 centimeter. Okay, so if you measure the distance between two wavefronts, then this measurement is 1.2 centimeter. And if it is 1.2 centimeter, then its wavelength is not 1.2 centimeter. Why? Because 1 centimeter equals to 4 centimeter. Then if the measurement is 1.2, then obviously wavelength will be different. And what will be wavelength in fast region? So it will be actually 12 fours are 48. It will be 4.8 centimeter. हाँ बेटा आमना और फारिया the concept is clear. Sir, we are given a diagram. In this diagram you are given this condition. This is a scale diagram. If this is a scale diagram, then by using ruler, you will measure the wavelength. And the wavelength is the separation between any two wavefronts. Okay. So this is obviously a digital diagram. If you have a printed diagram, then obviously by using ruler, you can measure the separation between any two wavefronts. But I have done this measurement, and this measurement is actually 1.2 centimeter. Okay. This is the scale diagram, and you are given this condition on diagram 1 centimeter, but it represents 4 centimeter. So if 1 centimeter equals to 4 centimeter, then my measured value, which is 1.2 centimeter, it will be actually 4.8 centimeter. Okay. So if you read the question is take measurement from ruler from the scale diagram. The question is what is the actual wavelength of water wave in the faster region. So I have explained earlier. So we will measure the separation between any two wavefronts. The measurement is 1.2 centimeter and actually it is equal to 4.8 centimeter. This is the actual wavelength. And now they are asking, what is the speed of the wave? What is the speed of the wave? Speed is equals to frequency into wavelength. No, no, sir, speed is given. Speed is given. Sir, speed is 0.39 meter per second. You have to calculate frequency. So wavelength should be in meters. And you know, centimeter can be converted into meter by using a prefix. And the prefix value is exponent minus 2. Whenever you remove centi, then the value of centi is exponent minus 2. Okay, so the wavelength is 0.39. Frequencies that we are calculating. The wavelength is 4.8 centimeters, so centimeter is converted into meter, and now you can calculate frequency easily. So we are not solving. Further, we are not solving. And the B part, draw lines, we have already drawn. And now the last part of the question. And I am asking this question by Arisha because Arisha was absent in the last two classes. Arisha, beta, when water wave exhibit refraction, then what is the change in frequency of water wave? Frequency will increase or decrease in shallow region. Arisha. It will decrease. Your answer is totally wrong because in refraction of water wave, there is no change in frequency. There is no change in frequency. Sir, why? The answer is V equal to F lambda, but the frequency of water wave depends upon frequency of vibrator, frequency of source. Okay, the source is producing water waves. Consider this is a motor connected vibrator, and this vibrator producing wave by vibration. For example, this vibrator vibrating 50 cycles per second. So the water waves will also vibrate with 50 vibration per second. And when they are traveling in fast region or in a slow region, frequency never change. So Arisha beta, note this important point. In refraction of water wave, in refraction of light wave, frequency remain constant, but speed and wavelength change. Speed and wavelength change. In deep water, speed is faster, wavelength is longer. In shallow region, speed slows down, wavelength becomes shorter. So speed and wavelength changes, speed and wavelength change as well as direction change, but frequency never change. Okay, I hope you must memorize and note this point. And now we are moving backward. The next question is this. This is October, November 2018. And the question is, this is a light ray, I think. A wave in air is incident on a glass, shows the wavefront at the glass boundary. The arrow shows the direction of travel of wavefronts. Okay, it is not mentioned that it is light or water wave. I think it will be light because light is traveling from air into glass. Okay, so this is light wave. And what is the question? The question is the wave undergoes reflection and refraction. Okay, at the boundary, draw, draw wavefronts of refracted waves. First, I am starting with refraction. We will do a reflection of water wave as well, but right now the wavefronts of refracted wave. Okay, so we are solving. Everyone knows the speed of light in air is fastest, and when what light enters into glass, then obviously it slows down, and I think its speed slows to 2.25 exponent 8. It slows down. And if speed slows down, then obviously wavelength will decrease. Wavelength will decrease. Okay, wavelength will decrease. Okay, so we are going to draw wavefronts. So this is the original wavefront. And I think if you start with wave, then it is more better. This is wave. Okay, this is wave. It is not wavefront. This is wave. The blue arrow. This is the wave. And in school, I think you have studied uh, light. This is the normal. This is the normal. And everyone knows when light enters into glass, it bends towards normal. It bends towards normal. Okay? बल्कि हमने भी आपको पढ़ाया था मुझे याद आ गया in light last week we have studied refraction of light and in refraction of light we have studied when light enters into glass when light enters into glass then it bends towards normal. Okay, so this is refracted wave, this is refracted ray, this is refracted ray. Okay, but you have to draw wavefronts. The question is draw wavefronts. Draw wavefronts. Okay, so I'm going to draw wavefronts. So wavefront drawing will be like this. Consider I'm using black color. This is the original wavefront. This is the original wavefront. Okay, but it will not remain straight. So it will bend. It will bend towards the boundary. It will bend. It will bend towards the boundary. It will bend towards the boundary. And now you can observe the wavelength, the separation of wavefronts decreased. The separation of wavefront decreased, but remain should remain parallel. Should remain parallel. Okay. So I have drawn refracted wavefronts. I have drawn refracted wavefronts. Okay. So I am not asking you to draw, but you should practice after my class because I am recording and I will share you my recording. So it is better कि आप उसको ड्रॉ करें और फिर मुझे व्हाट्सएप पे दिखाएं कि देखिए सर मैंने ये बनाया है. तो यू हैव टू ड्रॉ। अच्छा जी, और हम पीछे जा रहे हैं। सवाल, सर आपने रिफ्लेक्टेड वेव फ्रंट नहीं बनाए। वी विल ड्रॉ, वी विल ड्रॉ, बट फर्स्ट वी आर कंप्लीटिंग रिफ्रैक्शन। फर्स्ट वी आर कंप्लीटिंग रिफ्रैक्शन। अच्छा जी, I think it is the last question. Yes, it is the last question. It is the last question. Sir, again, in this question, the light is coming from eyes, like glass, and now it is entering into air. It is entering into air. But Arisha, can you tell me when light traveling from eyes into air, then speed of light will increase or decrease in air? Arisha, beta, the speed of light will increase or decrease in air? Yes, because the speed of light is fastest in air or in vacuum. Okay, number one. Number two, if I draw a normal, if I draw a normal at the point of incidence, then obviously the ray will not go straight. It will bend towards air, or sorry, towards normal or away from normal. Arisha, beta, can you help me? Where the ray will bend towards the normal or away from the normal? Towards the normal. It is totally wrong answer. It bends away from the normal. When light enters into air, it bends away from the normal. You should memorize it. This is the normal, and air in air, it bends away from the normal. Okay. And one more technique I think you can understand. If you write fast, अरीशा, बच्चे भूल जाते हैं कि किधर अवे करना है किधर टुवर्ड्स करना है, बच्चे भूल जाते हैं। तो गौर से सुनिएगा। इफ यू राइट फास्ट, then the medium where light speed is faster, then the light bends away from the normal. And the medium in which the light slows down, then the light ray bends towards the normal. ठीक है ना? So if you write fast, then you can easily answer, sir, if the light is in faster medium, then it bends away from the normal. If the light entering into a slow medium, then it bend towards the normal. जी बेटा अरीशा, ये टेक्निक आपको समझ में आई बेटा जो मैंने लिखी है? ठीक है बेटा। And now this is the ray. This is the rule for ray. And now I am going to draw wavefronts. Okay, I am going to draw wavefronts. Sir, wavefront number one. This is wavefront number one, and this is the original wavefront. This is the original wavefront. Then obviously, sir, the original wavefront will not go like this. Sir, it will bend, and it will bend towards towards like this. Sir, where towards? Oh, bhai, this wavefront, the first wavefront which I have drawn, it must be perpendicular on the ray. This is the ray. On the ray, wavefront must be perpendicular. Okay, and if you have drawn one wavefront, then obviously you can draw all wavefronts easily. You can draw all wavefronts easily because all the wavefronts are parallel to each other. As well as Arisha, can you tell me the speed is faster, then wavelength in air will be longer or shorter? Wavelength will be longer or shorter in air? Yes, because the speed is increase, wavelength increase, and now you can measure this separation is smaller and this separation is जी राफे बोलिए। इंक्रीज हो गई, इंक्रीज मैंने एरो गलत बना दिया, बट स्पीड इंक्रीज। सर व्हेन स्पीड इंक्रीज देन ऑब्वियसली वेवलेंथ इंक्रीज। ठीक है, और मेरी डायग्राम में भी आपको नजर आ रहा है the separation of wavefronts is increased. The separation of wavefront is increased. ठीक है? और याद रखिएगा first wavefront is very important to draw like this कि wavefront must be perpendicular on the ray. Wavefront must be perpendicular on the ray. एक wavefront अगर आपने perpendicular बना लिया, ठीक है जनाब, approximate perpendicular, then you can draw all the wavefront easily. ठीक है जी? बट दिस टॉपिक इज नॉट सिंपल। आप इसको बनाएंगे ना, अगर मैं आपको कोई नया सवाल पकड़ा दूं आप बहक जाएंगे। इसलिए जो बातें मैंने बोली हैं आपको बड़े ख्याल से उसको समझने की जरूरत है। अच्छा जी, दिस इज अनदर क्वेश्चन इन विच यू डू नॉट हैव टू ड्रॉ ड्रॉ द वेव फ्रंट्स, ऑलरेडी वेव फ्रंट्स आर गिवन। और बेटा अरीशा, ये मैंने आपके 5054 से डायग्राम कॉपी कट पेस्ट की है 5054 की, लेकिन ऑब्वियसली द कोर्स इज सेम। ठीक है ना, जाहिर सी बात है वेरिएंट डिफरेंट होते, लेकिन आप देखिएगा कोर्स आपको बेटा बिल्कुल सेम मिलेगा। ठीक है जी। अच्छा जी, इन दिस वे वी हैव कंप्लीटेड द टॉपिक refraction of water wave and refraction of wave fronts, and now I am going to teach you one more topic that is called reflection. I am starting one more topic that is reflection. जी बेटा। अब रिफ्लेक्शन मुश्किल है बेटा राफे, अगर जरूरी काम है तो आप जा सकते। अरे चलो ठीक है, चलो ठीक। एंड नाउ वी आर स्टार्टिंग। जी 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 जी। अच्छा जी, नाउ वी आर स्टार्टिंग द टॉपिक दैट इज रिफ्लेक्शन, एंड नाउ लेट्स सी व्हाट इज रिफ्लेक्शन। सर रिफ्लेक्शन में ये होगा, कंसीडर दिस इज बाउंड्री, दिस इज बाउंड्री, एंड ऑन दिस बाउंड्री you will be given wavefronts, you will be given wavefronts, and try to draw all the wavefronts parallel to each other. And if you draw at least four wavefronts, then it is enough. ठीक है? So this is a question which you are given. So all students first draw this question in your notebook. पहले बेटा इसको बनाइए, आप पहले आप इसको बनाइए फिर मैं आपको समझाऊंगा। पहले बेटा आप इसको बनाइए। And remember, all these parallel lines are wavefronts. This is a wavefront, this is a wavefront, all these are wavefronts. And a wave is coming like this. This is the wave. This is the wave, and parallel lines are wavefront. Parallel lines are wavefront. जी बेटा Arisha, have you drawn diagram of question? Okay. अच्छा जी, now I am going to explain how do you draw reflected wavefronts. ओके बेटा, नाउ आई एम गोइंग टू ड्रॉ रिफ्लेक्टेड वेव फ्रंट्स। ठीक है जी। अच्छा, रिफ्लेक्टेड वेव फ्रंट बनाने का जो ओरिजिनल मेथड है, इट इज सो डिफिकल्ट, वालेकुम सलाम, इट इज सो डिफिकल्ट, एंड इफ आई एक्सप्लेन द ओरिजिनल मेथड देन आई थिंक स्टूडेंट गेट कंफ्यूज। सो आई आई हैव प्लान्ड to explain you a दो number method or a simple method. So in exam, how will you draw? I'm going to explain. The method is if you draw a normal at the edge of wavefront, but this normal will be erased after drawing because it is not the original method. It is a do number method. Okay, so it is not original method. I am repeating again and again. We have to draw this normal as well. So first we will draw a normal at the edge of given wavefront and now measure this angle. Measure this angle. Consider, sir, this angle is 35. Consider this angle is 35 with normal. Then you will measure 35-degree angle on the right hand side. Then you will measure 35-degree angle on the right hand side. And then you will draw this wavefront. Okay. So first you draw and normal will be erased. Remember, normal will be erased. Normal will be erased later. So wavefront number one, sir, this is wavefront number one. And at the edge of wavefront number one, I have drawn a normal which I will erase. Measure angle with wavefront number one and normal. Consider it is 35-degree. Then on the same 35-degree angle on the right side, you should draw the reflected wavefront. You should draw the reflected wavefront. And if you have drawn, Navia beta, have you drawn this reflected wavefront number one? Okay, this is reflected wavefront number one. Then erase normal, erase this measurement, and now draw all normals, sorry, all wavefronts parallel to the first one. Draw other wavefronts which are parallel to each other. Draw wavefronts which are parallel to the first wavefront. Okay. So these are not rays. These are not rays. These are wavefronts G. And wavefront having no arrow. These are wavefronts. These are wavefronts. Okay. Or remember, sir, in reflection, there is no change in speed, no change in frequency, no change. What was, sir, what was the point of drawing the normal? It is your choice. You can pick any wavefront. You can draw normal. You should draw normal at the edge of any wavefront. At the edge of any wavefront, measure this angle, and on the same angle, draw wavefront on the right side. And then erase angle measurement and normal, and now draw this one. Then it is a perfect reflection of water waves wavefront diagram. No change in frequency, no change in speed, no change in wavelength, only direction change. This is called reflected wavefronts. So if you have drawn this, then you should share. At least any one student can share me. जी बेटा आमना आपने बहुत अच्छी बनाई थी डायग्राम मुझे याद आती है क्या आप हमें भेजेंगी डायग्राम आमना की नहीं हाँ आमना की सबसे अच्छी थी आमना बेटा आप हमें बना के भेजिए आमना आई एम वेटिंग डायग्राम फ्रॉम आमना और अगर बाकी बच्चे भी बना के भेज दें तो बहुत अच्छा होगा बट ऑल स्टूडेंट शुड यूज रूलर They should use sharp pencil, and I am waiting for reflected wavefronts. I am waiting for reflected wavefronts. Yes, your diagram is very good, but I think okay. But the issue is there is one issue. There is one issue. बल्कि नो इशू ठीक है परफेक्ट है परफेक्ट परफेक्ट बेहतरीन हाँ जी एनी अदर स्टूडेंट बेटा अम्मार आई थिंक यू शुड आइडेंटिफाई योरसेल्फ व्हाट आई एम टीचिंग फिजिक्स आई एम नॉट टीचिंग केमिस्ट्री बेटा अम्मार आई एम टीचिंग फिजिक्स नॉट टीचिंग केमिस्ट्री नॉट टीचिंग मैथमेटिक्स अरिशा बेटा जल्दी से बताओ डायग्राम दिखा रही हो आगे चले हम लोग फारिया बेटा आप दिखा रही है डायग्राम फारिया अरीशा ने भेज दी है हमें अरीशा की डायग्राम इट इज टेकिंग टाइम व्हाई टेकिंग टाइम जी नाउ दिस डायग्राम इज परफेक्ट अरीशा beta now this is perfect because all the lines are parallel to each other and your diagram is perfect right now and in the above diagram you can see the wavefronts are not parallel to each other that's why I rejected your diagram in the refraction ठीक है and I hope that you will redraw refraction as well अच्छा जी फारिया सर नॉट अच्छा जी फारिया ट्राई तो कीजिए फारिया जैसी भी बनी है दिखाइए बेटा फारिया आमना डायग्राम इज परफेक्ट and Varisha diagram is also perfect. I mean Nevia diagram is okay. Faria में भी okay ठीक है चलेगा. And now we should move forward. We should move forward. अच्छा जी in reflection we have completed and now I'm teaching you the last topic of today's class that is diffraction of water waves. But Amar, I am starting the topic diffraction. Some teachers say diffraction, some teachers say diffraction. So I am starting diffraction. Sir, what is diffraction? I am going to explain. Diffraction means consider this is again a ripple tank. In this ripple tank, consider these are wave fronts which are moving from left to right. Consider there is a barrier. This green line is a barrier. And if this green line is a barrier, then obviously these water waves cannot cross this barrier. But if I open this barrier, consider this is a barrier, and in this barrier, I make a very small slit. I made a very small slit. There is a slit, there is a slit, there is a gap. I think I should make larger gap because when I'm shading, then it becomes very narrow. Yes, this is a gap. And now you can see, sir, these blue vertical lines are wavefronts, and these wavefronts are hitting the green barrier, and the green barrier have a very narrow slit and very narrow gap at the center. And when these wavefronts pass through the slit, pass through the slit, then what happens? You will observe the water wavefronts shape will change. And this shape not only change, but you can see, sir, water waves when emerging from the slit, the water waves are spreading towards top and towards bottom. When water waves are emerging from a narrow slit, the water waves are spreading, and the spreading of water waves through a narrow slit. This is called diffraction of water waves. This is called diffraction of water waves. So if you write its proper definition, beta, note down the definition. When water waves or any kind of waves pass through a narrow slit and not necessary to be water. Okay, diffraction in all waves, okay, sound waves and light waves, etc. So when water waves pass through a narrow slit, a narrow slit, then spreading of water waves, spreading of water waves is called diffraction. The spreading of water waves is called diffraction. This is spreading. This is spreading. Okay. And in the next class, we will solve past paper questions.